My name is Brandon McGee, and I'm going over the technological advancements in transportation and how it's going to change our future. I want to start off by going over the electricity and magnetism concepts. First is going to be power capacity, which is how much energy is stored in the battery. Over time, chemists, physicists, scientists have all changed the power capacity of batteries, which has made big advancements. The same with the watt hour, which is the voltage that the battery can provide, which is multiplied by how much current the battery can provide for some amount of time. Now with that time is usually an hour, which is why it's called a watt hour. Over time, they have also made that even longer. Now the third thing I want to go over is magnetism. So magnetism is actually the motion of electric charge, which is resulting in attractive and repulsive forces between objects. And I'll show you some more about the magnetism later on in the slides. I want to start off by going over electrical vehicles. Over time, electrical vehicles become more and more popular. These are going to be the future that we're going to have. No longer going to have gas-powered combustion engines, nothing like that. It's all going to be powered by electricity because of all the benefits. Now to start, Robert Anderson first started off with a crude electric carriage. This carriage ran off of crude oil, which powered a battery and a motor that was connected to a carriage. So it'd be like it was basically the first horseless carriage. Now, there are three main types of electric vehicles that are also known as EVs. The first is the PHEV, which is considered a plug-in electric vehicle. The second is a BEV, which is a battery electric vehicle. And then you have your traditional hybrids. The first one I'm going to talk about is plug-in hybrid electric vehicles, which is also known as a PHEV. These plug into a power source. They have to be plugged into a power source to charge the battery. And on these, they have electric motors that will help and improve the miles per gallon of your gasoline engine. It kind of switches back and forth, and after you get to a certain speed, it'll kick on and help you cruise along and not take up so much gas. Now with these, they do have a short range, so if you're in the city, you're not going very far. You can run just only on the battery, but after you get past roughly say 80 miles, that gasoline engine is going to kick back on and you won't be able to use the battery anymore because it will be dead. Now these do lower the pollution, so like I was saying, if you're in the city riding around and you're just using the battery only, there is no pollution. But once you run out, the gas motor kicks on, there is going to be a little pollution still there. Now the next is going to be a traditional hybrid. These you do not plug into a power source. Now if you just have to, you would be able to. You'd charge it just like you would do a car battery, but these actually charge themselves. They have an alternator on there and a power generator, so as your gas motor turns, it turns and generates power to the battery and charges it. These do also have a dual power mode like I was talking about before, where it kind of switches back and forth between the battery and the actual gasoline motor at higher speeds, sometimes at lower speeds. This also is the same way. It has lower pollution than a typical gas motor because part-time it's able to run off of gas. This also helps improve your miles per gallon. Now the best advancement that's happened so far would be a battery electric vehicle. These run only off a battery. They run entirely off a battery only. There is no gas motor, no nothing to it, just an electric motor. Now these so far still have a short range. Over time in the future, these are going to have a whole lot higher range, and Tesla is actually working on that right now. But these must be charged by a power source because they don't have a gas motor inside of them to turn the generator to charge the battery in the back. These have to be plugged in. Now these have absolutely no pollution. There is no tailpipe to it because there's no exhaust coming out. And there is no sound pollution. These are very quiet. You don't have a motor making all the loud noise. You don't have a loud exhaust. Nothing with that. Now, like I was saying, Tesla is making some advancements. They have their Tesla Model 3. This car is fully battery powered. It's actually what we consider the fastest accelerating electric vehicle. It goes 0 to 60 miles per hour in 3.2 seconds. It has a 310-mile range, which is a whole lot better than the 80-mile range that I was talking about. So you can go a lot farther between charges. And these do have an all-wheel drive dual motor turning all wheels at the same time, being more efficient. The next thing I want to talk about, which is really big in the future that I really see happening a lot, would be a maglev train. Now maglev is just short for magnetic levitation. Now with this, the levitation happens by an electrodynamic suspension system. The electrodynamic suspension system is a superconductors that are exposed to time-varying magnetic fields. Now this induces eddy currents that are going to be in those conductors and create a repulsive magnetic field that holds the train off of the guideway. Now an easy example of this is that picture to the right. On top is going to be your train, the bottom is going to be your guideway. Now these repulsive magnets are there repelling against each other and pushing that train up where it is frictionless, it is levitating off of the guideway, not touching anything. Now maglev trains also have a guidance system that's similar to suspension system, also uses repulsive magnetic forces. Just like on both the Transrapid and the Transrapid guidance and the MLX guidance are both using those repulsive forces to keep the train centered inside of those guideways. So if it goes around a turn, it's going to repel against each other and keep that whole train centered. Now these maglev trains also have a propulsion system that is ran by magnets as well. It is just like an electric linear motor. As you can see on the right side of that picture, the light poles repel and push the train forward, so it's going in a linear motion, and the opposite poles are also attracting and pulling the train forward. So both magnets are working the same way, but they're both pushing it forward. Now these trains have many benefits. The speed is the #1 benefit that everyone sees. This train can go 375 miles per hour. So if we had a guideway, I should say, that goes from New York City to Los Angeles, you can make it there in 7 hours. And that is very fast to go all the way across the United States in 7 hours. That's like taking a flight. Now these are completely frictionless, makes them way easier to maintain because there are no parts to wear against each other. There's no wheels, no brakes, no tracks that are going to sit there and rub and wear down and have to be replaced. On a normal railroad, there are railroad ties that get old, rotten, wore out, have to be replaced. You don't have any of that. There is no noise pollution as well. They don't have a big horn on them to blow because they're not going to run somebody over because they're up 10 feet in the air on their own track. You also don't have the squeaky wheels, brakes, the rumbling of the train on the railroad either. And like I was saying, you're not going to run somebody over. There is a lot of safety features with this. It's going to be 10 feet off the ground, so animals will be able to go underneath it and not have to be running across the tracks and getting ran over. The same with humans. They don't have to sit here and cross these tracks. These tracks aren't going to be having an intersection where they have to blow their horns, or if the safety bars don't come down. Now the big problem with these is going to be the infrastructure. These are not compatible with the infrastructure that we have today when it comes to our normal railroads. So all the infrastructure is going to have to be built on its own, and they're going to have to find places for it to run through, ways to build it, fund it. There's just no way to actually do it. So if they can get the infrastructure down, this will be the future of our current trains and transportation. It will actually probably a lot cheaper and easier than getting on a plane because there won't be any jet fuel, no filling up the jet fuel. You won't have to be flying in the air and have a problem with falling back down. There won't be any of those fears. It's just going to be like riding in a car, except for you're going 375 miles an hour. these are going to be the sources that I have. The first is going to be the history of the electric car. The next is going to be the different types of electric vehicles. And I have all electric vehicles, the Model 3 Tesla, and then maglev, the magnetic levitation trains.